Welcome back, everyone, to 15-Minute Discourse. We're diving deep today into the world of solar flares. I've seen a lot of articles lately. People seem to be talking about them more and more. But, why should we be worried about something that's happening so far away?
Well, it's not just about distance, it's about impact. The more we depend on technology, the more vulnerable we become to these solar events. Our communication networks, our navigation systems, even power grids, they can all be affected.
Okay, so for those of us who, maybe haven't been keeping up with all the latest solar flare news, can we back up for a sec?
Imagine a massive burst of energy from the sun, like a giant eruption. It impacts all layers of the sun's atmosphere, the photosphere, chromosphere, and corona, and it releases energy across the entire electromagnetic spectrum, from radio waves to gamma rays.
And those rays, they can reach Earth.
They do, and they can cause some serious problems. One of the best ways to understand the potential impact is to look back at history. For example, the Carrington event of 1859.
Weren't telegraph systems going crazy all over the world?
It was more than just going crazy. Operators were getting electric shocks. Auroras, which you usually only see near the poles, were visible as far south as Cuba and Hawaii.
But that was way back in 1859. Our technology is so much more advanced now. Surely we're better protected, right?
Well, we've made progress, but even smaller storms can still cause disruptions. Like in 1921, there was a geomagnetic storm that disrupted telegraph service, even started some fires.
Really?
And then in August of 72, another storm disrupted terrestrial networks, damaged satellites, and get this,
What?
it actually detonated sea mines in Vietnam.
Detonated sea mines?
Yeah.
From a solar flare?
Yeah. It's kind of hard to grasp the power of these events when we're so far away.
I guess so. So if these things can cause so much disruption, can we at least predict them?
Predicting solar flares is tough. We've gotten better at it, but there's still a long way to go. We know that magnetically complex regions on the sun called delta spots often produce the largest flares, but pinpointing when and how strong a flare will be is still a challenge.
Oh, so it's kind of like earthquake predictions. We know where the fault lines are, but knowing exactly when and how strong the earthquake will be is still hard to do.
That's a good analogy. Organizations like NOAA are using data to make forecasts, estimating the probability of M or X-class flares within 24 or 48 hours.
Okay.
And there's also a tool called MAG4 that's being used to forecast flares, coronal mass ejections, also known as CMEs, and those solar energetic particle events, or SEPs we talked about earlier.
CMEs, what are those exactly?
A CME is like a huge burst of plasma and magnetic field coming from the sun's corona. They often happen with solar flares and can travel through space, sometimes reaching Earth and causing those geomagnetic storms we discussed.
Got it. So it sounds like there's hope for better predictions in the future, but what can we do right now to protect ourselves?
Mitigation is key. Power companies, for example, use alerts from places like the Space Weather Prediction Center to protect their grids. They can disconnect transformers or even do temporary blackouts to prevent wider damage.
So early warning systems and having a plan are crucial.
Yeah.
It seems like there's still so much we don't know about the sun and its impact on us.
Absolutely. And remember, the whole point of this deep dive is understanding those threats. So we need to keep learning and we need to keep researching this complex relationship between the sun and Earth. It's fascinating, really, and it's always changing.
Yeah, it really does show how everything's connected.
It does. The sun, Earth, our technology, it's all part of this delicate balance. And the further we push into space, the more important understanding that balance becomes.
Like a cosmic game of Jenga. You pull out the wrong piece and the whole thing falls apart.
I like that. It really speaks to why research is so important. There's so much we still don't know. For example, the connection between solar flares and something called sunquakes.
Sunquakes. Never heard of those. Are they like earthquakes, but on the sun?
Sort of. They do involve seismic waves, but on the sun, those waves ripple across the surface after a solar flare. And what's interesting is that scientists have found that the energy from some flares actually comes from way below the surface of the sun.
Below the surface? I thought solar flares were happening in the atmosphere.
They are, but the energy release can trigger events deeper down. Like back in 2011, there was a flare that released acoustic energy from about 1,000 kilometers beneath the photosphere that's the sun's visible surface.
Wow, that's deep. So what does that tell us about solar flares?
It's still a bit of a mystery, but it suggests that these sunquakes and the ripples they create could give us valuable clues about how big and how strong a flare might be. Imagine if we could predict not just if a flare will happen, but how much energy it'll release. That would change everything when it comes to mitigating the effects.
That would be amazing. Knowing not just if, but how bad. Sounds like there's a lot more to learn about these sunquakes. In the meantime, what can we do as individuals to prepare for these solar events?
Staying informed is a good start. NOAA and other organizations provide regular updates and alerts about space weather.
Like checking the space weather forecast.
Exactly. And it's always good to have a plan just in case there are power outages or disruptions to communication.
Right, so backup power, emergency supplies, that kind of thing. What else?
Don't underestimate the power of community. If there's widespread disruption, having a network of people you can rely on can make a big difference.
It's easy to forget that, especially in a world that's becoming more and more individualistic. It seems like this whole conversation about solar flares raises a bigger question. How do we balance relying on technology with being prepared for the things that could disrupt that technology?
That's a really important question. It's similar to the conversations we have about climate change. We need to understand the risks, take steps to mitigate them, and also adapt to the changes that are happening. And in both cases, both individual and collective action are essential.
It's empowering to know that we're not just helpless bystanders. We can do things to prepare for these challenges, even if we can't control them completely.
And knowledge is the first step. The more we learn, the better equipped we are to make informed decisions and protect ourselves and our communities.
This whole deep dive has really shown how interconnected everything is. We've gone from talking about historical events to the science behind solar flares to the impact on society as a whole.
And it all comes back to the fact that events happening millions of kilometers away can directly affect our lives.
It is a pretty sobering thought, but also pretty fascinating. It's like we're constantly trying to solve this giant cosmic puzzle, and the sun is one of the most important pieces.
And each new discovery gives us another piece of that puzzle. But it also reminds us that the universe is full of surprises. We can't predict everything, especially when it comes to something as dynamic and unpredictable as the sun.
True, but it's still amazing to think about how far we've come in understanding solar flares.
Absolutely. Our knowledge was so limited just a few decades ago. Think about it. Early observations were limited to what we could see in visible light, and the instruments we had then, well, they were nothing compared to what we have today.
So it's like trying to study a fireworks display through a tiny little peephole. We're only getting a glimpse of the whole picture.
That's a great analogy. But now, with space-based telescopes and much more sensitive instruments, our view has expanded incredibly. We can see solar flares across the entire electromagnetic spectrum, which gives us a much more complete picture of what's happening.
It's incredible how far we've come in such a short time. And it sounds like things are just getting started.
Definitely. One of the most exciting areas of research right now is using AI to predict solar flares.
AI, like artificial intelligence.
Yeah. Researchers are training AI algorithms on huge amounts of data from past flares, hoping to spot patterns that humans might miss.
So it's like teaching the AI to recognize the warning signs before a solar storm even happens.
Exactly. And the results are really promising. Some models are already predicting flares more accurately than traditional methods. It could completely revolutionize our ability to prepare.
It's pretty mind-blowing.
Yeah.
But even with the best predictions, there'll always be some level of uncertainty, right?
Of course. The sun is incredibly complex. We can't expect to predict its behavior perfectly. That's why focusing on resilience is so important.
So it's not just about better predictions. It's about making sure our systems can handle the disruptions that do happen.
Exactly. We need to design everything, our infrastructure, our technology, with space weather in mind.
It's like building a house in earthquake country. You need to make sure it can withstand the shaking.
Perfect analogy. And just like with earthquake preparedness, we need to take action on multiple levels. We need government policies that prioritize space weather resilience, technological innovations that make our systems less vulnerable, and individual actions that help us prepare for potential disruptions.
It's a team effort. It's realizing that we're all in this together, that we're all part of this web of interconnected systems, and that a disruption in one area can affect everything else.
It's a reminder of our place in the universe. We often think of ourselves as separate, but events happening millions of kilometers away, like these solar flares, can have a direct impact on our lives.
It's humbling, but also awe-inspiring. Understanding these connections is crucial for our survival.
Absolutely. And it's a journey that's ongoing. There's still so much to learn. But by collaborating, sharing knowledge, and embracing innovation, we can meet the challenges of space weather head-on and build a better future.
You mentioned earlier that there could be potential benefits to solar flares as well.
Oh, right. We tend to focus on the negative, but there are some positives too.
Well, they do create those incredible auroras, the northern and southern lights. That's a direct result of those charged particles from the sun interacting with Earth's atmosphere.
Exactly. And who knows, maybe there are other benefits we haven't discovered yet. Maybe hidden opportunities, even resources that we could harness from these events.
Now, that's an interesting thought. It's a good reminder that even in the face of potential threats, there's always room for discovery and innovation. Maybe by studying these events further, we can not only protect ourselves, but also find ways to use them to our advantage.
I love that perspective. It really speaks to the importance of staying curious and open-minded as we learn more about the sun and its impact on our planet.
It really is amazing how much we've learned about solar flares, even just in this deep dive.
Yeah, we've gone from thinking of them as just these distant events to really understanding how much they can affect our lives here on Earth.
It shows how science can help us see those connections.
It really does. We tend to think of space as this empty void, but it's full of energy and forces that directly impact us.
And it feels like the more we learn, the more we realize how much we still don't know.
That's the beauty of it. There's still so many unanswered questions about the sun, about solar flares, about how it all affects us.
It's like we're putting together a giant cosmic puzzle.
Exactly. And every discovery gives us another piece of that puzzle, helps us see the bigger picture.
It's amazing to think how much progress we've made in such a short time, especially considering how little we knew just a few decades ago. You were saying earlier how back then we could only observe flares in visible light.
Right. It was like trying to understand a whole symphony by listening to just one instrument. We were missing so much of the complexity.
Yeah, so much of the picture. But now with all the new technology, with space-based telescopes, we can see so much more.
We can. Now we can observe flares across the entire electromagnetic spectrum, which gives us a much more complete understanding of what's happening.
It's like going from one instrument to a full orchestra. We're getting the full picture now.
Exactly. And this new perspective has been crucial for learning more about flares and their potential impact. But of course, we're not stopping there. The research is constantly evolving, pushing the boundaries of what we know.
Like that work you mentioned earlier about using AI to predict solar flares. That sounds like something out of a sci-fi movie.
I know, right? But it's really happening. Scientists are training AI algorithms to analyze huge amounts of data from past flares, looking for patterns that humans might miss.
So teaching a computer to recognize the signs of a solar storm before it even happens.
Exactly. And the results so far are really encouraging. Some of these AI models are already predicting flares more accurately than traditional methods.
That's incredible. It could completely change how we prepare for these events.
It could. But of course, even with the best AI, we can't expect to eliminate uncertainty completely. The sun is incredibly complex, and there's always going to be an element of unpredictability.
So it's not enough to just have better predictions. We also need to make sure our systems can handle the disruptions that do happen.
You got it. We need to design our infrastructure and technology with space weather in mind from the start.
Kind of like building a house in an earthquake zone. You don't just rely on earthquake predictions. You make sure the house is built to withstand the shaking.
That's a perfect analogy. And just like with earthquake preparedness, we need to take a multi-pronged approach. We need government policies that prioritize space weather resilience, technological innovations that make our systems less vulnerable, and individuals taking steps to prepare for potential disruptions.
It takes all of us working together, recognizing that we're all connected, that a problem in one area can have ripple effects everywhere else.
Exactly. It's a good reminder of how we fit into the grand scheme of things. We might feel separate, but events happening millions of kilometers away, like these solar flares, can have a very real impact on us.
It's a humbling thought. But it's also a reminder of how important it is to understand these connections, not just for scientific curiosity, but for our survival.
Absolutely, and this is just the beginning. There's still so much more to learn and discover. But by working together, sharing our knowledge, and innovating, we can face these challenges and create a better future.
Well, this deep dive has been an amazing journey. We've explored the history of solar flares, the science behind them, the threats they pose, and even some of the potential benefits. I hope our listeners have enjoyed it as much as we have.
It's been a pleasure sharing this with you all.
And before we sign off, we want to hear from you, our listeners. What are your thoughts on what we've discussed today? What questions do you have? Head over to the comment section below and let us know. And while you're there, don't forget to like this video and subscribe to our channel for more deep dives into the fascinating world around us.
We're always exploring, and we'd love for you to join us.
Until next time, keep looking up, keep asking questions, and keep exploring the wonders of the universe.